To brief you about what we have on our agenda for you today, we will first, there would be an address by the head of the Department of Electronic and Telecommunication Engineering, followed by a keynote speech. And then we will introduce the course to you and explain the course logistics, how the course will be conducted and the course outline. And then that would be followed by a Q&A session where you can ask any question that you have and get your clarifications done. So first of all, we would like to invite Dr. Ranga Rodrigo, who is the head of the Department of Electronic and Telecommunication Engineering at University of Moratuwa, Sri Lanka. He obtained his bachelor's degree in Electronic and Telecommunication Engineering from the University of Moratuwa in 2001 and obtained his PhD in Computer Vision from the Western University of Canada in 2008. So I cordially invite you to address this gathering.
Thank you, Chatuni. May I be given permission to share the screen? Yes, thank you very much for the invitation and the introduction. Welcome all of you to the microcontroller-based design course. So I need to talk about what our department is first, and then I will briefly talk about why we offer this program. So the electronics department of the University of Moratuwa, as you know, is very well known for its electronic design and telecom skills. And we attract the best students of the advanced level A-level stream. So we have a great community and we have a great knowledge base of microcontroller-based embedded system design and many other electronic, telecom, and biomedical areas. So we want to make that knowledge available to you also. That is why this program has been organized. So as we see, a university is a place where we preserve knowledge. That means we have a lot of knowledge with us. Then we share knowledge. This program is also one of the avenues using which we want to share our knowledge. Of course, we can share our knowledge with our students who come to the university. And you know, it is very difficult to cater for a larger organization, larger batch of students by getting them to the university. That's why we have to create avenues like this to share our knowledge. Of course, we create knowledge also through our research. So ours is a very well-established department, 100 for bioelectronics and 16 for biomedical. We have a lot of staff members, many laboratories and so on. So in the past also, our department students have done extremely well, winning world competitions in 2009, world championships in IEEE X3 programming competition, signal processing cup, top conference papers, and so on. Yeah, so we have a large number of staff members. So this program will be mainly conducted by Dr. Subodha Charles. He has expertise, serious expertise obtained from Sri Lanka and from University of Florida in the US on embedded systems. Actually, he specializes in embedded system security also, which is an important aspect in the current world. Yes. So these staff members have obtained their qualifications from places around the world, mainly from North America, then from Europe, and then of course our undergraduate degrees are in Sri Lanka, and then from Japan, Australia, New Zealand, and so on. Yeah, so we have so many tracks in the department. Electronics is one of the tracks. Telecom, biomedical engineering, robotics, computer vision and pattern recognition, which I specialize in, reconfigurable hardware. That means programming our circuits onto field programmable gate arrays and getting them working like ICs, then embedded systems and so on. Yes. So if you take the journey of a telecom student, so maybe that person will just do a basic alarm clock at the very beginning. And then later on in semester 3, maybe design small robots, then even more complicated circuits and more complicated circuits. And then maybe acquire signals from the human body and process them, then design slightly more complicated circuits. Now these are advanced. And then the final picture that you see is the flexible electronics work done by Kitmin and others. Actually, Mr. Kitmin Vikramsinghe, who is joining from British Columbia, Canada right now, will also be a lecturer in this course. So you can see people who have acquired serious knowledge in this area will be talking in this course. So therefore, the experience and knowledge that you get will be very practical. very practical. So Dr. Subodha will detail about this, the orientation of this course. We have chosen a method that will actually get you to do these things. It is not just theoretical knowledge, it is the ability to do. That is what is important to function as a person who designs these things and make a contribution to the industry. Yes, then we have other tracks. I will not talk about all these things. The telecom track, what we do in telecom, the advanced projects that we do, and then the biomedical engineering work that we do. This is also related to electronics because we use a lot of electronics for biomedical work. Kitmi's picture is here again. And then the robotics work. So many robots are designed, battle robots, and then slightly more serious robots later on. And then we have another track for pattern recognition and computer vision. Pattern recognition is the more theoretical term for machine learning. Then these are some robots that people have designed now. In all these things, microcontrollers are there. In the robot arm that you see on the top right, they have devices. Now, all these devices, the basics of programming them, basics of getting them to work, are required for you to come up with a large scale design like this. These are all undergraduate projects. So we will also make you aware of how to get started in this area. These are very exciting for us. I hope that they are exciting to you also. So some other projects that we have done in the autonomous driving area, Professor Rohan Munisingha's work in, you can see unmanned aerial vehicles, we call them drones, and then some collaborative robotics work here. So this collaborative robotics work, where there are 3 robots, as you can see, was done under my guidance and Dr. Keshala Jayasekara's guidance. We were very excited about this. You can see there is a camera that detects all these little things, and then the robots are given a high-level task, and they are supposed to understand that task and make something like a building. So these are like, think about these like bricks, and they are bringing the bricks together, and the robot arm is making that building. So you see that these are very complicated systems. A lot of thinking has to happen to design systems like that. But beforehand, before everything, you have to know how to get a robot running, how to get some microcontroller controlling the robot, right? So those are the basics that we will not teach you how to design a robot here, but the microcontroller work will be taught here. So see, the microcontrollers, semiconductors, and so on have a very high demand. So all the markets are growing. So the biggest application in microcontrollers is in the automobile industry. Maybe you did not think like that. So maybe there was a difficulty in automobile manufacturers, that means car manufacturers, to produce cars recently. Actually, one of the reasons was the lack of microcontrollers. Because of the COVID pandemic, people could not make many microcontrollers, and then the companies did not have enough of them. So therefore, you can see the microcontroller market is growing very fast, and the applications are growing very fast. So people who are able to design with these things is very much required in the industry. One more trend is, if you think about the market trends, most of the microcontrollers are bought by Asia Pacific, the China's, India's, and of course we are also part of that region. Why? Because the designs and design skills and some parts of manufacturing have moved in this area. So therefore, it is very good that you also participate in this and gain some knowledge out of that. So as a country, we also should play a prominent role in this area. See, there are many things that we can engage in as a country. We have the garment industry, we have the software industry, we have the rubber, coconut tea industry, we have the tourism industry, but why not the high-tech industry through microcontrollers? So this is why we think when 5G, AI, IoTs, Industry 4.0, when all these things come together, we want to see how our brains can be put together, like yours, like mine, like the teachers that we have in this, to empower people in Sri Lanka in embedded design, so that we can project Sri Lanka toward economic growth. So this is the purpose of the department getting involved in this and gathering up this excellent panel of lecturers. Mr. Abarajithan is joining. Mr. Abarajithan is a person who worked extensively in the FPGA area. He has surpassing knowledge in these areas. So the lecturers who are here, including Chatuni, maybe you have heard who she has been in high school. So these have serious expertise in this area. Whatever the question that you have, they will have an answer. So therefore, benefit from their wealth of experience and their teaching, and try to enhance your skills of actually doing these things. Think about the certificate and the ability to add this line in your CV as just a byproduct. Your actual knowledge and skills are what is important. So that is my wish for you, that you go through this course, get the maximum benefit out of this, be able to design something, and your confidence levels and your skills and abilities will improve. It will be beneficial for our country and beneficial for you also, economically and otherwise. So thank you very much, all the organizers, for organizing this, and thank you very much for trusting our department people to be able to deliver this program and joining. I wish you all the very best for the course. Thank you.
Thank you very much, Dr. Ranga, for giving such a broad idea about the field and the importance of learning microcontroller-based embedded system design to set the right tone as we begin the third iteration of our bootcamp. Yes. Next, what we have up on our agenda is the keynote speech.
Hello.
Yes.
All right.
Is Abaya. Yeah, I would give a brief introduction to our keynote speaker. We have Mr. Abarajithan Gnaneswaran as our keynote speaker for the day today, and he obtained his bachelor's degree in electronic and telecommunication engineering from University of Manitoba in 2020. And he's currently a PhD student at University of California, San Diego in the United States. He was formerly a lecturer and currently a consultant at University of Manitoba, a former intern at Qualcomm and AMD, and a former RTL design engineer at Lemurian Labs. I invite Mr. Abarajithan to continue with the keynote speech.
All right. So, hello everyone. I hope I'm audible. All right, great. So
you are audible, yes.
Great. All right. So yeah. So today we are about to have like a overall look of microcontrollers and the embedded system industry. So I have put a photo over here which you are very familiar with. So it's all over the news. You know about the Apple Vision Pro, right? So we'll briefly talk about the sort of embedded stuff that's going on there, which is very impressive, and the chip that Apple has like designed specifically for this product, Apple Vision Pro as well, the R1 chip, which like takes all the sensor information and processes the stuff. So we'll see like how important this field is, and we will see its roots, and we'll see like where you'll be going as well. All right, so we can start. All right. So yeah, about me, I guess like Chatrini has covered most of this, and we can start from the next slide. All right. So basically, the story of electronics. So like the very roots of electronics actually go back to communication, telecommunication. So you know that back in what 1800s, so in 1877 and before that, so like when Alexander Graham Bell first invented the telephone and patented it, right? So multiple people invented around same time. So he painted in first, and then like they established a company and they started like providing this service, right, of telephones. So that is where you see like the boom of like electronics and a lot of technologies related to that. So if you see the first commercial telephone, so back in the day, so it had like no amplifications. So it can only carry the signal to like 3 miles. Okay, and the connections were fixed. So you can set up one from maybe a shop to your home, which is like 3 miles away or something. Okay, only one connection, and you can just call your home. You can't call anywhere else, right? So right. So what I mean, this gave like a lot of issues. So for an example, without amplification, people have to like shout a lot, and like so there were like booths where you get in, and like you sometimes you shout. Okay, so and you can't carry the signal more than like 3 miles, because like the signal gets like so weak, you won't be able to do that, right? So over time, like they introduced different technologies, and one of these, the groundbreaking technology was vacuum tubes, right? So vacuum tubes were like the small light bulbs, right? Small old light bulb, filament light bulbs, okay, but with 3 terminals, right? So they were the first real amplifiers. So these were basically discovered or like invented so around the 1920s in Bell Labs. Okay, so basically almost everything about electronics and telecommunication were invented in Bell Labs before say 1950 or something, right? So even afterwards, even today, like all the innovation happens in companies that were born in Bell Labs, right? So which is why this book is a excellent book if you want to know the history of electronics and telecommunication. So the Idea Factory, Bell Labs, and the Great Age of American Innovation, right? So they talk about like how what all this came through, and how they engineered to generate these new ideas, and how they engineered innovation, right? All right. So this vacuum tube was born there. So basically, like they suddenly had an idea. So so at that point, they could only do like a few miles, so maybe like 20-30 miles of telephone, right? So these high level executives, they had an idea. Okay, so in about 10 years, there's going to be an exhibition on the opposite side of America. Okay, so that is like 4,000 kilometers something, right? Like between what New York to what San Francisco, right? So let's do like a cross-continental phone call in that what exhibition. So they came up with the idea, and they saw, okay, what's the problem? So the problem is we can't get the signal more than 20 miles. So how do you take it to like say 4,000 kilometers, right? So for that, like they hired like a bunch of people, and so one of them was a physics PhD guy. So there were no like electronics engineers back then. There was no electronics as a field. So this guy came in and he was experimenting with different stuff, and nobody understood like how things work. So it was not very scientific. So he was like randomly putting horsehair and like say silver and like random different type of wires, okay, mixing and matching. And somehow he ended up with a vacuum tube, right? So he invented by brute force. So that is how the innovation worked just before Bell Labs, right? So and later only, even today, like we actually doing a more scientifically driven innovation, where like you actually look at the properties of materials and do some research and like stuff like that, right? So back in the day, it was more like tinkering. So he tinkered vacuum tube, and then like within like next 5 years, they laid all the cables and like put all the repeaters made up of vacuum tubes, and had the first phone call. So they brought Alexander Graham Bell and his assistant Watson. So they put them on both ends, and they were like, okay, what he called, and he was like, yeah, Watson, I need you here. That is the famous first lines talked in telephone call. So they repeated that as a publicity stunt, right? So this was due to vacuum tubes, and this became so popular, right? So and then in the next 20-30 years, like everybody was buying all these like radios and everything made up of vacuum tubes. So and like this really took off. So it was a household item, but even then it was huge. It was like a huge microwave oven, or like an oven sized, right? You can see the size of the like tubes and everything, and it was very hot, and they broke often. Okay, and they need a lot of power as well. All right. So then in 1945, so in the same year, they like came up with the atom bomb. Like they also invented the transistor, right? So which is a far bigger like achievement, right? So and again, that was invented in Bell Labs, and this time by like multidisciplinary group. So some were like working with materials, and some were like writing equations, quantum mechanics equations. So like they all like sort of worked together and figured out the first transistor. And then that revolutionized the field once again, right? So now the things that were the size of your oven like comes down to like your pocket, right? So the transistors are again amplifiers. It's the same thing as a vacuum tube. They do the same job as a vacuum tube, right? But in a slightly different way. And they are far more efficient, far more reliable, and extremely cheap and extremely small. That's the most important part, right? So, and this happens only in our industry, right? So in other industries, like you can maybe like you have trade-offs, like so you can either make things small or you can make it reliable or stuff like that. Okay, so in electronics, especially with all this like the transistors and like chips and microcontrollers, so every few years, everything becomes smaller, everything becomes faster, and everything becomes cheaper, right? So this field has been accelerating in exponential rate ever since then, right? All right. So that was a modern story of like small like microelectronics. So at the same time, the story of computing. Okay, so actual programming and making things compute. So that has been even longer, right? It's not a new thing. So the oldest computers we know about are like from Greece, like 2,200 years ago, right? So this was found in a shipwreck. It's called an Antikythera mechanism. So we believe that this simulates the movement of sun, moon, and 5 planets, right? It's an analog computer that kind of calculates different eclipses and stuff like that. But we don't know for sure because we haven't built a working copy of it, right? So the computing is like quite old. People have been doing this for like thousands of years. But in 1800s, again, there was a rise of analog computers. So people built different sort of things like integrated mechanism, but for particular purposes, right? So one of the first ones were built by Lord Kelvin, right? So the guy who you may know about as the guy with the name for Kelvin, right? The temperature. So he was a physicist, and he built one of the first analog computers to like calculate the tide, do integration and stuff like that. Okay, so afterwards in 1820, right. So yeah, so you have the analytical engine built by Charles Babbage, and it calculated the log, sine, costan tables for navigation, right? So back in the day, like it was very important to very difficult to find your location when you are navigating in the sea, right? There is no GPS. So without GPS, the only way you can reliably identify is like you have to do mathematical calculations based on the position of the sun and stars and everything. And also like you have to keep an accurate record of time, and that way like you can see how far apart and the time is changing and all. So to do this calculation, you need sine, cos, and tan formulas, right? Like the actual values and all these things. So the like the logbooks we used in our A levels. So these were actually used for like very high precision stuff, and they were computed by like some machines. So then, like in 1940s, you have the military computers. So you have ENIAC from US military. So this was programmed by 6 women. So the first programmers were actually women. So even the for the moon missions as well, like the moon lander and all was programmed by a famous woman. So and you have like 30 tons and 18,000 vacuum tubes inside this. Okay, so the whole it was a huge thing, like size of a building, and it was used to calculate the paths of ballistic missiles, right? Projectiles and all. All right. So okay. So yeah, then so that was analog computing, right? So if you go for the digital computing, so first IC it was in 1958. So in Texas Instruments, they basically put a couple of transistors together in one slab. Okay, so and that was the first IC. Then they refined it and they start building handheld calculators, right? So TI is still famous, like they are selling calculators all across America and around the world as well. So they do that. So in 1971, it was Intel. Okay, so they came up with the 4904, right? So this is a very famous chip. So 4-bit and 2000 transistors. It was to be used in portable calculators. So this whole chip was designed by like one guy. So one guy and his assistant, 2 people. So he manually drew it by hand and like put everything together. And yeah, so it was the entire chip design was done by hand in large sheets of paper, right? So that's how they built this chip. And then you have like the smartphone socks today. So which is not a microcontroller, but it's a processor, right? So it's a system on chip. It has a processor and it has like some other stuff, GPU and all these things together. Okay. So in terms of computing, all right. So it has 6.7 billion transistors. Okay. So a simple calculator today, it has the power of like 350 Apollo computers. So what is that? So the computers that were used to land a man on the moon. Okay. So we have calculators, our normal calculators are 350 times faster than those. Okay, have more performance than them. And if you take a random phone, a simple phone, it is 120 million times more powerful than the computers used to put the man on the moon. Okay, so today you can take your phone, you can download a horoscope app or something, or a star chart, and you can do the same computing that was done by the Greeks 2200 years ago, right? So basically, it's like a full circle. You can do the same thing today as well, right? So then the question is like you have all these kind of chips and everything, but how can we get our hands on that and how can we play with that and stuff, right? With all this computing. So Raspberry Pi is again a microprocessor and ARM system on chip. So it can run a full operating system, Linux. Okay, so it's not really a microcontroller. So it's used to control robot arms and drones and gardening and all these things. So it's basically a full computer, which was introduced in 2012. And I'm sure you might have known about that. And it's very cheap. You can buy and you can program that and do stuff as well. So we have that kind of a power in our hand today. So that's the message. All right. So from there, like if you look at the embedded systems market, okay, so like all this sounds great. So all the history sounds great. But then what is the reality? What's happening with the embedded system industry? So when you say embedded systems, it's often like not, it's basically with the micro controllers. So basically there's no operating system. It's used to control stuff, right? Control different applications. So this embedded system market is huge. Okay, so you have like what um, by 2023 it was like 191, right? So 91 to 98 billion USD around the world, and it is ever growing in an exponential rate. Okay, so there is always market for this, and this is much harder than regular software engineering. So which means you have like much better software, but job security as well as like you get to do a lot of things as well, right? So this is a little bit more information about what Dr. Ranga talked about, the global chip shortage, right? So nobody talked about these embedded systems, about microcontrollers and the chips and all of these things. So like it was only people like us were talking in these kind of small sessions, okay? But then like 2 years ago, when there was right after the pandemic, so this became a huge headline that there's a global chip shortage, right? So when you say chip shortage, is not just like big processors and all these things. So then only we found the normal people found out that most of these chips are being used in the automotive industry. So all this like the car manufacturers and all these things, they came to a halt, right? So during pandemic times, there was like a slump in chip production. So during that time, and then like after the pandemic, the what people started buying a lot of cars, and like the car companies ramped up the manufacturing, but then they suddenly came to a stop because like there were not enough chips, right? So there were lines and lines of cars just sitting in the factories. So without chips to put inside it. So where do you think these chips are being used inside these cars? So not just these Teslas, right? So like Teslas and EVs, so you know that they are like mobile computers, right? So they have Wi-Fi and they have all these things, and like they have a big, beautiful screen and all, right? So no, if you take even a small, simple car, right? Like any car you can take, like even like I say you take a Tata Nano or something, all right? So that's one of the cheapest cars, right? So even that car, inside that you have like what, hundreds of chips, right? So especially like if you what the windows to make it go up and down, and in some cases like your what in some cars you have the brakes, okay. So and most importantly, in most of the cars today you have the fuel injector, right? So the one that controls the fuel intake, so it's not mechanically controlled anymore in most cars. So they use a chip called fuel injector, which which controls the precise timing, opening and closing of valves to do that, right? And that improves the efficiency a lot. So this way, there are like tons of chips in places you don't even think about, okay, around you. So if you take like any kind of like random thing, so even like a remote control or like you'd see the green color PCB, printed circuit board everywhere, right? So like all these are powered by embedded computing, right? So these PCBs are made like that and they are controlled like that. So this is like the entire world runs on this, and a lot of people don't really think about this. Okay, so yeah, so like the auto industry, they lost about 61 billions of sales. Okay, so due to the chip shortage. So this is like the different countries got affected. So China got affected the most because they were the ones who are ramping up a lot. And yeah, so now let's talk about this. Okay, so you know about the Apple Vision Pro. Okay, so now everyone is talking about it. It was released a few days ago. There are a lot of YouTube videos. So and Apple is introduced like a new paradigm called spatial computing. So you basically put on your these glasses, and you can like, so you can change the surrounding and you control the whole thing with your eyes, right? So you look at different things and you click and all these things, right? So to make the whole thing work, so inside you have an M2 chip. So a lot of people know about the M2 chip. It's a processor, right? So it's like in the Apple Silicon custom processors, which came from their they used it in MacBook and all these things. It was there for some years. But then you have a new chip in this Vision Pro that's called the R1, right? So and this chip is a microcontroller. So it's a microcontroller, and the purpose of this chip is basically to process data from all these sensors. Okay, so in a Vision Pro, you have like countless sensors like this, and so basically 12 cameras. Okay, so one of these has 12 cameras and 5 like different sensors, and you have 6 microphones from everywhere. So the job of the R1 chip is to get data from all of this and process. So what are these sensors? The sensors are, there's a LiDAR scanner to find to make a 3D map of your room, right, as a point cloud. So and it constantly keeps updating this room, like because it gets what reconstructed inside your headset, right? So for that, like it keeps scanning this room in this way. And then you have the Apple True Depth camera as well. So to find the like the stereo cameras and stuff. So and all this data from all these sensors is being processed within 12 milliseconds. And this is absolutely critical for something like a VR headset, which Apple doesn't like calling it, right? They want to call it spatial computing. Why? Because people don't like VR, right? So, but like at the end of the day, like there's a problem with the VR headsets. That is, if the latency is a little bit too high, then people get dizzy, right? So if you are wearing this and if you turn your head and if your vision turns a little bit late, okay, so you are going to get dizzy. So, and this is a big problem with Meta's headset and like other headsets as well. So the cheap headset, so you can't use it more than like a few minutes, right? So, and they have been trying to fix it as well. So in Apple, they like as usual, they got like a ground up approach. So they have their own systems and own new microprocessor, which can process all this information within 12 milliseconds, right? So that way, like when you're turning your head and stuff, like it feels so natural and stuff. So this is basically a huge embedded system in your eyes, right? This is more than like a regular computer, right? So it's like it has so many sensors collecting data, processing, and like running and all these things. So this is the like the bread and butter of embedded system engineers. So the stuff that you will learn throughout this course, right? Like how to get data from sensors, like process, and like all these things, right? So the exact same thing is happening here, but in a massive scale, right? So in a very optimized scale, and the possibilities are endless over here. So you can see that the field is always finding new venues every few months, right? So someone comes up with something. So like nobody thought like, I mean, you will have some sort of this kind of headset before, right? And Apple did it. And with that, like you're going to have like even more applications and stuff. So that way the industry keeps going forward, creating new solutions. And so that way growing faster than anything. All right. So from that, like we will quickly go through our the differences between a microcontroller and a microprocessor. Okay, so they are like in general, like they are kind of similar. So one of the main differences, like you don't in a microcontroller, you don't typically run an operating system. Although there are some systems like Mu, so like microcontroller, Linux, so some redundant systems like that. Okay. So in general, they are like an electronic machine. So you can think of it as an electronic machine. So it's a tiny programmable computer, right? So usually they are like very low power. You can run for days or months on battery. Okay. So this is the thing for like IoT and like edge applications. And usually the microcontrollers are extremely cheap. So 200 to 1,500 rupees. So now they might have gone up like a little bit. And you can use this to automate the tasks at home and to build and sell products, right? So you can do all these things. So you can make your own business out of it. So after doing this course, so we'll be basically guiding you on that. So you have like a microcontroller, and it basically takes some inputs and generates some outputs, right? Quite simple. So using a computer, you program the microcontroller. So you write your own code and you program it to see what to do with those inputs to get the outputs. So for an example, if you want to adjust a fan speed automatically based on temperature. So if it's too hot, you want the fan to go fast. If it is too cold, you want to reduce the fan or stop the fan. So for that, the input will be a temperature sensor and the output will be a speed controller to connect to the fan. The second one, if you want to water your plants in the garden, then the input is a humidity sensor. You check whether the land is dry and stuff like that. And the output is basically a relay switch, which opens up a valve, right? So, and the third one is like if you want to fill a water tank. So if you fill a water tank, it overflows. So you want to measure the level and stop. So input is a water level sensor, output is a relay switch. So similarly, you have like multiple applications. So like you can even have like a voice controlled AI system. The input is a microphone and output is anything. So here you can see like a common pattern. The output is never a motor or something that moves, right? So it's always a motor controller, relay switch, and all these things. The reason for this is because microcontrollers are controllers. So they control small amounts of current, right? So they can't give like several amperes typically, right? So because of that, what we do is you are able to get the like when you from a microcontroller, you can change the speed controller and stuff. So using a pin, And then you have to use some sort of amplifier to control whatever you are controlling, right? So you need a transistor, or you need a motor controller which consists of a transistor. So you have relay switch or stuff like that. So because the microcontroller cannot handle too much current, right? But the things that you want to control needs too much current. So to bridge that, you need all this extra stuff. So which we'll teach about in this course as well. So you will be doing projects where you use those. All right. So basically, a program is like very simple. You have this sort of um, we'll teach you about like how to write these languages and all these things. So on the algorithm is basically you check the humidity. So the humidity sensor will keep giving you numbers. So you check the humidity, and if the number is less than some value, then it's dry, right? So then you say like, oh, give 5 volt to this pin. Okay, so this is basically to water a plant or something. Okay, so you check the humidity. If it is less than a threshold, you gives 5 volt. If it is more than a threshold, you give 0 volt. So that's kind of the simplest system. You can improve on it, but this is the simplest idea, right? So the C code will be something straightforward like this. So we'll teach you how to do all this. And then if you compile this code, you're going to get assembly, right? So this is assembly. So what is assembly? Assembly is the language of the microcontroller, right? Microcontroller's architecture. So after you assemble all this, you are going to get ones and zeros. And then you push these ones and zeros into your particular microcontroller, and you can watch it work, right? So this is the kind of the general task. So almost all the applications that we do, like it's always the same. You go through this entire process, right? So if you are looking for options, then there are like countless options of microcontrollers. So you have very powerful ones and very simple ones. So you have like 80 tiny, 85. So you can see like it has a very small RAM and like small number of pins, 32 pins, 8 pins. Okay, and it's cheaper as well, right? So if you are running a business, or if you are working for some company, and if you are building a product, then it's very important for you to find this microcontrollers, like to choose which microcontroller to use, right? So based on your specifications, and that is what we are going to like look in this course as well. Okay, so we'll give some pointers about how to pick these particular microcontrollers for your application. All right. So Arduino kind of made this very popular. So it's like a microcontroller for the masses. So before this, you have to go and search all these specs and find things. So now you can just take an Arduino and you can prototype. And later on, you can go and look and find a microcontroller to make your own product, right? So these are parts of Arduino. You'll be taught in more about this. And yeah, so these are the multiple different development boards. So you have Arduino Uno, Nano, and you have Blue Pill, STM32, and then you have Pi board. So you can even program it with Python, which is not very advisable. So like some people, like there's an ecosystem around it now, but we will teach you C and C++, which is more widely used, like it's used in a lot of places, right? So you have a huge ecosystem around that. Okay. So there is a common misconception, right? So one thing is, if you like look at this right-hand side, so in Sri Lanka, you have every year there's a lot of inventions and innovations, right? Exhibitions and all, but only very few of those come to the market. Okay, so the reason for that, why? So is what like Elon Musk is mentioning here. Okay, so you can see the prototypes are easy, but production is hard. Okay, so there's a common misconception in Sri Lanka and like among a lot of students as well, that whatever we do as like with Arduino and stuff, that is the actual product. Okay, it's not. So there's also another saying that often your semester projects or final year projects, so it's built so that one test case can pass. right? You do a demo and the demo passes and everybody's good and happy and you graduate, right? But in a company, you have to build your product so that no test case can fail, right? So which is a huge, infinitely harder problem, right? So, and doing that reliably, cheaply, and all these things, it's very difficult. Okay. So the difference between prototype and product development is basically in prototype, you have a high unit cost. So if you take an Arduino and if you buy sensors from sensor boards to connect to Arduino and everything, it's going to cost quite some money, right? But if you after you prototype with that, and if you go and build your own circuit board, PCB, which we will teach you in this course, then you can cut the cost by like order of magnitude, right? Maybe like by 10 times or even more than that. Okay, it'll be much cheaper to make your own boards, right? So this way, like there are a lot of types of prototypes as well, and usually the prototypes don't. So and it's not mass manufacturable. So we don't look at these when doing prototype, right? So, but when you are going for product development, you have to think about those, right? So basically, there are two types of product development. You have to the general one, user driven. You have to find out what your user wants and everything, and then you have to design. Another one is design driven, which Apple does. They don't ask anybody; they just make a phone, and they know that people will buy. Okay, so that is very risky, and doing that will make you bankrupt. Okay, more often than not. Okay, so then like usually when you say product development, it is user driven, right? Like you have to find out what the user wants, and then you have to kind of like tailor to that. Okay, so the prototypes can be of simulations. So you will have some introduction to simulations as well. So the microcontroller codes and circuits you can actually simulate online. Okay, so there are like different applications and stuff. So right, and that way you can optimize your stuff and then go for production later. Okay, so here is a quick story about optimizing your stuff to the specifications, right? So right, so this is basically these are two airplanes, and these are made by like Lockheed Martin, right? Lockheed Martin, the company in USA for American Air Force, right? So the Skunk Works is actually a small branch of Lockheed Martin R&D, and they built like all these planes like it was a small team. So what happened was like back in 1970s and 1960s. So you have the Cold War between America and Soviet Russia, right? So during the Cold War time, so the military wanted these planes urgently. So specifically like they wanted the Blackbird and stuff urgently to spy on Soviet airspace, right? They want to take photographs and see what they are doing and all these things, and they wanted to do it fast. So, so they contacted so they gave contracts, and Lockheed Martin won that. So and they gave some specifications. So basically, your plane has to fly like so high and so fast and all these things. So and this was never imagined before. Like nobody has built anything like this or anything remotely like this. Okay. So but it was so out of this one. So like even the company decided, okay, if we try to build it, we are not going to build it. Okay, why? It's a big company and you can't do all this. Like it will take forever to decide on something. So they collected a small group of very smart engineers, and like they didn't have anywhere to go. Like they didn't give them any room or anything. So they put a tent outside a kind of plastic factory. So which is why it smelled really bad. So they named the team Skunkworks, right? So this Skunkworks is the like one of the top aviation like design teams in the world. Okay, so there's a link over here which is from the like which tells you the story in more detail, right? So yeah, and so one of the planes they designed is like the Nighthawk. Okay, so 1981. So this was designed later, right? So if you look at there is Nighthawk is this plane. Okay, this one. So you can see it looks like an origami, kind of like a caricature plane. Like what it doesn't look like it can fly also, right? So it looks like a paper airplane, right? So and it actually cannot fly. Okay, so it is unstable in all three axes. So which means when the pilot tries to fly it, it actually wobbles and it tries to fall all the time, right? Why? The reason the specification asks for stealth. So they wanted to avoid a radar at all cost. So they don't want to be identified. So it has to be extremely stealthy. So, but the problem was back in the day, like you didn't have big computers and everything to design like these radar surfaces. So the whole idea of stealth is when you send a radar signal, it reflects and it comes back. That's how you identify the plane, right? So what if it reflects and doesn't come back? What if reflections goes somewhere else? Then you can't identify the plane, right? So you have to design the surface that way. So none of the surface should send the radar signal back, right? So because of this, but the problem is there's no good computers, not powerful computers to calculate these surfaces, so curved surfaces. So the only computers they had like were strong enough, powerful enough to do this kind of like flat surface. So they made the whole plane out of flat surface, okay, and it was a wild success. So like they couldn't even see the plane when testing it. So they put the plane on a pole. So they saw the pole, but they didn't see the plane. So they did the job like so well. But then the plane couldn't fly, right? The plane is supposed to fly, but this couldn't fly. So what they did was like they put this stabilizers. So you have, this passenger crafts are like stable, right? Like in all three axes. But the fighter planes are not stable in one axis. Why? Because they want to turn very fast. So in that axis, they put a computer, okay, small control machine to control it. And that is also, again, an embedded system, right? So here what they did was they put three of those computers in all three axes. So basically there are three computers dedicated to keep the plane upright all the time. Okay, so it's not aerodynamic at all. So even the pilots say like it's always wobbles when you're trying to fly it. Okay, but it is so successful, it has never been shut down except once by mistake, right? So then it's a very successful plane and it's still in service, right? Then I talk. So similarly, this is a Blackbird. So this plane leaks fuel. Okay, so like this, there are holes in its body. So when like the plane tries to take off or something, it leaks a lot of fuel and stuff, and it can't start its own engine. So it has like a bunch of issues as well. So why? So the reason again, optimizing to the specification, right? So the specification given was it has to be faster than Mach 3. So that is 3,600 kilometers per hour. This is still the record for the fastest plane. Okay. So, the fastest plane. So the commercial planes go around 300 to 500 kilometers an hour. So this is 3,600 kilometers per hour. Okay. And the ceiling was more than 85,000 feet. Okay. So the idea is like you can't shoot down this place. Back then, even the missiles couldn't reach it. And missiles first this could outrun the missiles. Okay. So it was designed like that. And it served for like 40 years. So they basically like got some specifications optimized to that. Okay, so which means you have to remove everything that is not needed. Okay, optimized to that, and built it within 143 days in a tent. And for 40 years, the America is still using it. Okay, and the record is unbroken from 1960s even to today. Like nothing has flown past there, right? So yeah. Right. So that is about the spirit of engineering in general. Right. So this way, like you have all this boards to do your prototyping, so you can test your stuff. But when you go for a product, you have to cut down everything that you don't need. Okay. So specifically, you don't need an Arduino. So Arduino like has all these peripherals and all these things, which makes it expensive as well. So you don't need any of that. You cut down, you bring it down to the bare bones, and make it a product, right? So which you will learn in this course, right? So that is how you cut the unit price, and that's how you you or your company will make money, right? Okay. So similarly, like you have multiple product development boards, and you can use that to build different stuff on as a prototype. Okay. So then you go for a final prototype where you make a board like this. You use a PCB design using these LTM tools, which we will teach in this course. And then like you make a final prototype with all this what enclosures and all that using 3D software and all. And you have to look into manufacturing concerns and stuff like that. So that will be the final prototype, right? So which is going to be translated to product. And finally, you go for actual product development. So you can here you can see like PCBs being mass manufactured, okay, and you have like even enclosures being mass manufactured. So this is how all the stuff that we have around us, your TVs, your laptops, and everything is made like this. So like you have a whole process of like going through that, right? So finally, we will. These are some examples. So of the stuff that like people in electronics have done, ENTC. So these were students about your age, okay, like first year to final year in the university. And so this is basically it means final year project. So you can see it's messaging it's monitoring the EMG sensors, right? EMG signals. So you have all the the sensors were custom designed, okay, and these PCB boards and like all the soldering and everything was done by themselves. So and they put so it's basically a wearable. You wear it, and when you hold, you grab your hand and you release your hand. You do different things. So and it measures the signals that go from your brain and like and stuff, translates it into like it decodes the messages and it translates it to like an environment in the computer, right? So this is like biomedical kind of like prosthetic research, right? So and this was built by our like students, so Kidmin and his team, right? So you can ask more questions about this from him. So this is Kidmin's another project. It's a micro mouse. So micro mouse is basically it has to be extremely fast, right? That is its requirement. So in that case, but yeah, so it has to be extremely fast. It's basically a small robot that solves a maze. It goes around and solves a maze. So to do that, you need like really fast control loops, and then you need to build the entire board to sustain that, right? So this is like the design and the final product over here. So this is my final year project. So this is vision-based control, traffic control. So basically the idea is like in a junction, you have 4 cameras on 4 sides. So you process the live video on a chip. So on a custom chip, it's called an FPGA, where we can design our own chips inside it. So which runs this object detection algorithm, CNNs, and based on that, it runs our custom algorithms, and finally calculates the green times you have to give on every side. So it'll be like an automated system. So this is a quadruped robot, okay, built by Resh and his team. So this is a 4-legged robot, and it can. Why? The reason for this is better than the wheeled robots when you are walking through like rough terrain. So the wheels always get stuck, or like one of them will always get lifted or stuff like that. But the like legged robots are very good at walking uneven terrains, sandy, muddy, hard, and like rocky terrains, right? So they design the legs and everything themselves, and like the entire systems, and like they programmed and like all that. Yeah. So this is an IoT project, like from Tamidu's group, Elephant Collar. So, and it was funded by Mahavali Development Project. So it's a low power IoT device, which has a battery life of 3 years, right? So they connect this, and it can it basically monitors the location and everything of the elephants. So to prevent human-elephant conflict, right? So and it has the communication protocol is NB-IoT. All right. So these are some inspiration of Sri Lankans doing great work. So even in Vision Pro, we had a graduate from like our senior Aya. So he did like great work like in Moratoa, then like he in USA, and he worked in Apple, and he contributed to the Vision Pro as well, right? So this way, people around us are like doing a lot of great things. So especially even Sri Lankans are like doing like all these things around the world, right? So in Sri Lanka and abroad as well. So even in Sri Lanka, you have like a lot of companies which are doing these projects, embedded projects, and collaborating with foreign companies, exporting and doing a lot of stuff, right? So this way you have so much potential, right? To and a lot of job opportunities, career opportunities. So in this area. So as well as you can see that this field is always improving, and they are finding new venues like the Vision Pro, spatial computing and stuff. So there's always opportunity for this. So if you get good at this, like you're going to definitely get into one of these, right? So the difference is like when you say if you take like general software engineering or stuff like that, I personally believe that they like this kind of work is much harder than general software engineering, right? Because you need to know both hardware and the software, right? So it is quite a bit harder like than that. So because of that, there are not a lot of people who are trying to work on this, right? So only a few people are actively getting into this field. So because of this, you have like a lot of job security. So now you have heard of like layoffs all over the place and everything. Okay. So this affects the software engineering more than like hardware or embedded, right? So that way it's like a very secure field that pays you a lot, as well as it's around the world, right? So I will send these links in the group. All right. So that is basically the end of my talk. Right. Thank you. Thank you so much.
Thank you very much, Mr. Abarajithan, for that very insightful keynote speech. I believe next we can move on to the introduction of the course and the explanation of the course logistics that will be done by Dr. Subodha. So I cordially invite Dr. Subodha to continue with the session.
Thank you, Chandani. Good morning, everyone. Let me share my screen, making sure that I'm sharing the right screen and that you can hear me without any issues.
Yeah, we can see your screen properly and hear you.
Thank you. Well, good morning, everyone. We are glad to have you. So I don't plan on taking a lot of time talking about the content because most of the stuff Abarajithan covered in a very interesting manner. So it's very hard to top it off. So I'll tell you what you can expect in this course and also what are the next steps that you need to follow if you would like to enroll in this course. So I'll stick to that. Also, a quick reminder, if you have any questions, you can drop them. Kitmin has shared this Mentimeter chat, not the chat, the Mentimeter link. So there's a QR code as well. You can scan that and ask any questions there. We'll be, at the end of today's session, we'll be covering all the questions and we'll give the answers accordingly. Right. So I'll keep my video off in case anybody is having bandwidth issues. We want to make sure that you can hear us rather than seeing us, because hearing is more important in this case. So I'll turn it off for now. Okay, so a quick introduction about the course, what you can expect, and we'll be happy to clarify your questions as well, as I mentioned earlier. A brief introduction about myself. I'm currently a senior lecturer at ENTC. I graduated from the same department, and I did my PhD on embedded system security from the University of Florida in the US. Prior to joining ENTC, I had experience at Zone 24/7, a company in Sri Lanka, and at Intel in the US. So again, a quick reminder, any questions, you can drop them here. What you have to do is you have to go to menti.com on your phone, and you will be asked to enter a code, and the code is here. Or else you can scan the QR code and you will be taken to Mentimeter. So please keep the questions coming. We'll keep an eye out of for any questions that comes in as well. Right. So these slides, I will not be spending too much time here because Abba already covered all of them. It's everywhere. Basically, that's the message that we want to give you. You see a lot of people coming out as like software graduates, which is perfect. At the same time, we want to make sure that there are options available to Sri Lankan students if they would like to go into the domain of embedded systems. So embedded systems is widely regarded to be the future of computing. As you can see, the embedded systems have a presence in almost all the places that you can think of, whether it's automobile, medical, entertainment, automation. So they're everywhere, which is why the demand for people who can do this properly is huge. That is our primary motivation of giving this information out to you, because these modules were traditionally taught within the university. They were not exposed to the general public, but now we are doing that because, as Dr. Ranga mentioned in the beginning, ENTC gets 100 students every year. That is not enough to cater to the requirement. Because if you're listening closely to Dr. Ranga's presentation, even within ENTC, there are different pathways that people can take. One, for example, is electronics, these embedded systems. There can be machine vision, there can be like pattern recognition stuff, can be telecom, can be robotics. So there are multiple options. So out of the 100, even a smaller number of people actually go into embedded systems. So that is why we need the numbers to increase. For that, we need to teach this to more people. That is our primary motivation. There are a few others as well. I'll get to them. Right? So it's everywhere. And we want to make sure that we equip you with the capabilities of the future of computing. Because when you think about it, in the early days, as Abba showed, the computers were the size of a room. And then they started becoming smaller and smaller. Then in the 1990s and the early 2000s, you had mainly general purpose computing, meaning that you have a PC that looks, I'm sure you know what a desktop computer looks like with the CRT monitors. It looked like that. And it could run Microsoft Word, can browse the internet, can run some other applications like games and all that. So that is general purpose. But now people are moving towards more application specific. I'll touch upon these things in a bit more detail. That shift is what we need to capture. So you saw during Abba's talk, the market trend, the increasing potential of embedded systems you saw. And in Sri Lanka, people say that the electronics industry is not mature enough. Well, it's a cycle. If we have people with more skills, more opportunities will come in, and then more people will, a trend will develop, more people will get into this domain. That is what we want to make sure that happens. Because most of the time when a new company, let's say a foreign company wants to establish a branch in Sri Lanka, one good example is Synopsys. Synopsys is a multi-billion-dollar, like a Fortune 500 company, and they have a presence in Sri Lanka. That happened because they can find the talent. So if we can find the talent for a particular industry in Sri Lanka, getting the opportunities is not as challenging as training people, right? Because always people, these companies, they are in the lookout for talent. And if there is an ecosystem where they could move and get benefit out of it, they will of course come, right? So that is why we need to establish the talent first, and that is the primary motivation of us doing that. So when we talk about embedded systems, there are multiple specializations even within embedded systems that one can take. One is the hardware aspect, computer architecture. We talked about processors earlier, and the programming side of things, firmware and embedded operating systems as well. Then communication, because these devices, especially with the emergence of things like IoT, these things talk to each other. In addition to the devices talking to each other, there is communication within the device as well. So there are multiple communication protocols. And then finally, when you look at the consumer aspect of it, these devices has to look good. So things like product design, enclosure design comes in. Out of these major areas in embedded systems, our focus will mainly be here on the embedded hardware aspect and also the programming, the firmware side of things. So we will not be teaching you how to develop a processor. We will be teaching you how to take a processor or a microcontroller, mainly a microcontroller, how to take a microcontroller and connect sensors and actuators to it and develop the firmware to read the data process them, make decisions, and make an impact back on the world through the actuators. So that is our focus. When you have that skill, there are many multinational companies who are looking for people that has this skill set. So working for these companies for a Sri Lankan, that's not impossible. I mean, you saw the talks earlier, you saw some examples, and many people are currently, if you go to a company like this, it's not very difficult to find a Sri Lankan working there. So we need to increase the numbers. Because when you compare the global market with the Sri Lankan market is definitely not up to the standard, meaning that we still need to meet like revenue targets, getting foreign revenue, all these things we need to increase. So this 406.9 million is like peanuts compared to the market value that can be captured at the global scale. So if we have the skill, like I mentioned earlier, then we will be able to capture at least a part of that value. That is critical as a nation, because when you compare the NIEs, the newly industrialized, most of the countries, you take Singapore, Vietnam, Taiwan, you can see the type of exports, the product exports, they are much higher, like orders of magnitude higher compared to the service exports. But in Sri Lanka, what has happened? In Sri Lanka, we are like almost the same. So we are mainly generating revenue out of services, not from products. And even from products, this 11 some billion dollars, they come from other products, not high-tech products. Can be tea, for example, right? But when you compare the global scale, the high-tech manufacturing industries, even if you capture like 0.1% of the global market, that is a huge amount compared to the Sri Lanka's GDP, right? So that is why we think training people in these high-tech industries, these technologies, is not important. It's actually essential for the growth of the country. That is why as a department, as people who have the knowledge, we thought we want to make sure that more people can acquire this knowledge. Right. So with that motivation in place, let me quickly walk you through what you can expect in this course. I don't plan on spending too much time in these slides introducing what embedded systems are to you, because Abha did that perfectly. This is the general purpose and the embedded system distinction that I wanted to make. So I was earlier telling you about a general purpose computer like your laptop or your desktop that can run multiple applications. Compared to that, embedded systems are developed for a specific task. So we can go on and on about the differences, but I hope you can understand the main difference. So when you look at an embedded system, it's mainly a combination of a processor, some power mechanism which powers up your hardware, and some external hardware as well that can do things, right? And then we connect an external programmer to these embedded systems, to this processor, and we install a target application. So Abha showed you how the C code gets converted into assembly and then eventually gets loaded to the internal memory so that we can do those things. So we use a host machine to develop that. So as embedded systems programmers, you will be working here, mostly developing the firmware, and then you program your embedded system. Typically, this programmer debugger that comes together with the PCB in most cases, or else you can plug something from the outside as well. So here is an example of such a development platform. This is the Simple Link Texas Instruments Launchpad. You can see the major components that we talked about earlier: the processor, the power system, and the onboard programmer debugger that connects to the host machine, that is your laptop or the desktop where you are developing your firmware. That connects through this port over here, and it can program your processor. So when talking about this processor, one instance or one solution for this processing core, it is a microcontroller, right? And another solution is a microprocessor. So we explained you the difference between a microcontroller and a microprocessor. Here you can see it has registers. These are memory locations where you store the instructions and the data to be executed. There is a clock subsystem that synchronizes everything. There's power management. There is a bus controller for communication. There is memory and external input-output as well. So this is what a typical microcontroller looks like. And if you try to map this block diagram into a real microcontroller, you can see if I overlay the basic elements of a MSP, this is again the microcontroller that is powering the launchpad. If I overlap, you can see, sorry, I was clicking somewhere else. You can see that these main elements are actually present there, right? So this is what we are dealing with. Now, these kind of microcontrollers are everywhere. If you take a car, for example, it is going to be a very complex system, and it's not just one embedded system. So now you know that if you don't close the door, an indicator comes up. That is actually one system, that small functionality that has like a sensor in the door, whether to check whether it's closed or not, and then it communicates with the vehicle control unit, and then it has to go to the dashboard, to the indicators, then it comes up. So an automobile is actually a combination of embedded systems, because if we go with this complexity, it is very hard for us to understand. In this course, we are going to use a simplified block diagram. So the way that we will understand embedded systems is that we sense the environment through sensors, and the sensor data is sent to the embedded computing platform, our processor. And to do that, most of the time, the sensors will have to be converted into digital, the sensor data. Because if you get analog data, it has to be converted into digital. Well, if it's digital, then you can interface that directly. Yes, can be some other interfacing mechanisms as well. But if it's analog, you go through an AD converter. And on the other hand, once you process the information and you make some decisions, you either display them or else you make some change back on the environment through actuators. So if the actuator is running on analog, then there'll be another digital to analog converter as well. So here is the block diagram that we will deal with. You will see sensors, you will see actuators, you will see display, you will see embedded computing when we go through the course. So that is what we are dealing with as an overview. Now let's go into some details, like specific details about what you will face in this course. Here is the outline of the course. We are starting from like mid-February, and this runs until May with some holidays in the middle to cover the Sinhala and Hindu Urdu period. This we will be giving to you, everybody enrolling in the course. We'll walk you through this. But before I go into like details about what the schedule is going to be, that can happen later as well, let me touch upon the topics that we are going to cover. So these topics will be covered through a course project. So it is not going to be the case where we give you the theory and we ask you to figure out what to do. That is not going to be the case. From day one, well, day one is actually today, so let me say day two. From day two onwards, you will be developing a product with us. And we will teach you microcontroller programming, PCB designing, connecting to the cloud, all these concepts while developing the product. So that is why Dr. Ranga in his initial thoughts shared that this is going to teach you how to actually build things. It's going to be an outcome-oriented, hands-on kind of a course, right? So especially we understand that your requirement will be to build things. And also once you have the basic understanding, to build on top of it, right? So to do that, you need to get your hands dirty. There is no other way. Okay. So the course project we will be building is the Smart Medibox. So what is that? That is a device to remind you to take your medication on time. Let's say somebody in your house has to take medicine on a regular basis. I hope not, but that might happen. In that case, can you remind those people you have to take a few pills before you have your meal, or maybe after you have your meal, one at daytime, one at night. So you set reminders and you alert them when they need to take your medicine, right? That is the basic application. To do this, we have multiple input-output mechanisms. Inputs, in this case, are push buttons. This is how you set the alarm, just like you set an alarm on your mobile phone. We don't have a touch screen, of course. We have push buttons so that you can set the time. We also have temperature and humidity sensors because these are important to make sure that your medicine is at the correct environmental conditions. That is why we monitor them. If there is extra moisture, for example, that can be bad for the medicine, and we show that on a dashboard. Outputs. These outputs are mainly what alerts you when to take medicine. We have a buzzer that is a device that makes sound, a buzzer. And then for visual feedback, we have the display, an OLED display, and LED bulbs that indicate you different things. Communication, this will be connected to Wi-Fi and through that to the, connected to the Wi-Fi and through that to the internet. Therefore, you will be able to send some sensor data to the cloud. And at the same time, you will be able to issue commands through an online dashboard. So it's bidirectional communication. Here are the features: ring an alarm when it's time to take medicine, ringing the alarm to notify when the temperature or humidity is not within recommended level, display the time, date, and alarm information on a display, setting the time and date up on startup, and monitor and control through a web dashboard. So this is what you will be developing throughout these days that we outlined. Okay, so there are approximately 16 days through 8 weeks. That is what you will be building. So we'll teach you some theory, how it works, and we'll sit with you and develop this step by step. And if you get stuck, we will provide you feedback, we'll guide you. So it's mainly like we actually, even in some of the promotional videos, we mentioned this. We thought of calling this a boot camp, because this is not a typical course that you see in universities, because a typical course has lectures. We have lectures, yes, but this is mostly coaching, mentoring, guiding you to build this. That is what we will use our live sessions for, right? So it's going to be a flipped approach where you have recorded content that you should watch, and then we get together and we build it together. We will guide you if you hit any roadblocks. So while developing this course project, you will be exposed to a few concepts. As you can see, PCB designing, schematic designing is one of them. Here is what the 3D visualization looks like of the Medibox. These are the topics that we will cover while we develop the Medibox, starting from microcontroller programming. So here, we first give you the basics. From the very basics, in fact, where you blink an LED, right? That is the first step. So if you are an absolute beginner for this area, microcontroller programming, that is fine. We will teach you from blinking an LED, connecting wires together on a breadboard using fritzing, and seeing this in action. Okay, so we start from there. We teach you the basics of microcontroller programming, and then we move on to developing our Medibox. Once we have a hang of this firmware development component, then you have a working thing. You simulate the functional components using simulators. You have something working. Then we will translate our breadboard wiring into the PCB schematic design, and then from there to the PCB layout, right? So even for the PCB layout and schematic, we'll be using a very basic tool first initially called ECEDA. That's an online tool where you will not really face the complexity of like professional PCB designing software. So it's a good starting point for you as a beginner. Then once you have the firmware developed, you have the PCB developed, then the next step is to combine the two. So in this combining process, we also make sure we give you some best practices, because doing something and doing something correctly are two different things. Maybe you can get it working, but maybe if you run this device for a month or so, due to some electrical standards not being met, things can go wrong. So what are the best practices to make sure that it doesn't work once, it actually works throughout the time, right? So the lifetime is extended, right? So with those best practices, we will combine everything, and then we'll show you how to upload the firmware and get the Medibox up and running. All right. So once we complete these steps, we are done with the first version of the Medibox. But remember, up to this point, we still did not connect our Medibox to the cloud. That will come later. Once we have the basic idea of firmware development, microcontroller programming, PCB designing, then we will go into some advanced concepts, right? So we have a dedicated few lectures, one on in-depth microcontroller concepts, and also how to use professional PCB designing tools, because you started from something very basic, something like Altium Circuit Maker, for example, how to use them, we will talk about. Because these professional PCB designing tools, they give you more capabilities. For something like a Medibox, the basic one, ECEDA will be sufficient, but our objective is not to stop here. We want to give you the tools so that you can develop something on your own. For that, you at some point might need the professional EDA tools that gives you more flexibility, more things to do. So therefore, we will touch upon that once you are familiar with the basics through a simpler tool. Then, towards the end of this course, we will come to connecting to the cloud. So we'll connect our Medibox to the cloud. As I mentioned earlier, it's going to talk with the cloud and also receive commands from the cloud as well. Then once we establish those connections, then we will start setting up our dashboard. Here is a dummy dashboard. As you can see, it has some dials. Maybe you can show your temperature and humidity like this. Your alarms can show a clock, show like a countdown clock. How long do you have to take your medicine? And all these things can be set up on the dashboard. So for this dashboard, we are using an online platform called Node-RED. Don't worry, if you don't have web development knowledge, like JavaScript, for example, that's okay. Node-RED makes things much more easier. It's like drag and drop and a little bit of customization. So the amount of JavaScript you need to understand and do this, we will provide you. And then finally, we will connect the dots. As a conclusion, we will give you an idea about the embedded product development flow, where we start with a concept, we identify the specifications, we look at hardware and software resources we have, we see how we can implement some in hardware and some in software, and finally put this together to develop an embedded system. So this is exactly the same thing that you are doing in the Medibox, even though we don't really synthesize anything on hardware. Those are like more advanced stuff, but this still, the basic idea is there. And then we verify and evaluate. So we'll stop by giving you this overview, because through SkillSurf, we have actually delivered a more advanced electronic embedded product design course as well. But for you to go there, you need to start from the basics. So that is why we have this beginners level course. So once you take this, you will be well prepared to take the future courses. Well, of course, taking the future courses or not, that's completely up to you. That's a separate course. But if you don't have this knowledge, you cannot take the future courses. So Abba talked about the Apple Vision Pro and like the camera system and how it operates. So that's all exciting work. For you to be able to go there, and even in the Vision Pro, it's not one person developing this, like hundreds of engineers. Even for you to contribute to one component, the basics are important, right? So the more advanced electronic product development things will come in the future. This is where we lay the foundation, right? And we also have another course on edge computing. Edge computing is where you train your machine learning workloads using you make inferences using microcontrollers rather than putting data in the cloud and making inferences there, right? So if you have, let's say, have a CCTV camera system, then you see some image, rather than you having to send the image to the cloud to make decisions, can you get some decisions at the camera level itself, right? So that's one example I hope you can understand, right? So these are all more advanced concepts that will be built on top of this foundation that we are laying here. So when we, by the way, just a quick check. Am I still clearly audible? The slide took a little bit of time to load. That's what I'm checking. That's why I'm checking.
Yes, you're audible. You're clearly audible.
Thank you. Yeah, the internet connection can do funny things from time to time. All right. So now why is my slide not moving forward? Okay, it decided to move forward. Right. So throughout this entire exercise, you will be familiar with several tools like the walkthrough simulator, fritzing, ECEDA. That's a PCB schematic and layout design thing. Then Altium Circuit Maker, the Arduino IDE, where you will spend time developing firmware. The Node-RED dashboard, that is where you develop the dashboard after connecting to the cloud. And VS Code also mainly used for C++ programming. It's more of a professional IDE, right? So I hope you got an idea about what you will face in this course. Since I've been talking for a while and you've been listening to us for about 1.5 hours, let's go to some questions. We'll answer them and we'll use the remaining, 20 to 15 minutes to go through the course logistics. So do we have any questions that came up? Right now, I'm looking at Mentimeter. It says no questions from the audience. Let's look at the chat as well. Right. Question on the Zoom chat. How much will it cost to purchase all the hardware required and where can I purchase them from? Right. First of all, for you to complete the course, you don't have to purchase hardware. Everything can be done using online simulation and design tools. That is possible. However, we recommend you purchase the hardware because you can actually then touch and feel and see your thing working, right? So if you would like to take that option, we offer you two options. One, that was actually my next slide. One, we can send you the bill of materials, like the list of things to buy and where to buy it. Then you can purchase. Approximately, it will cost about 6,000 rupees. And the 6,000 we have estimated, including the project components, PCB manufacturing with soldering and packaging and courier fee, altogether 6,000. So now you might be thinking, if I'm purchasing things by myself, why do I need to pay for courier? Well, you don't. That cost estimate is given because we have another option where one of the technical officers at ENTC will purchase this, everything in bulk. Well, actually, the 6,000 is the bulk cost because if you're purchasing more items, the per unit cost goes down. So we'll purchase that and we'll send it to you. If you prefer the soldering to be done by us also, that is possible, but you can get the PCB and the components separately and do the soldering yourself as well. So all these options are available. I hope I answered your question. Anything else that you would like to get to know?
There's a question in the chat. Will we get some notes?
Yeah, well, okay, there's another one. Yeah, so notes in the sense we'll be sharing the slides with you and you will be getting recorded lectures. All the content will be recorded and delivered through an LMS. I'll walk you through the LMS in a few minutes. You will get notes in that sense, yes. Okay. Another question. I am about to move to auto electrical industry, passed out from NDT Morato under mechanical engineering. With your expertise, can you advise the paths will be opening related? Okay, especially by following the course. Let me try to understand this properly. Okay, so if you're a person into auto electrical industry, I hope you got an idea about what we will be covering in this course. Using that knowledge, you can develop products for different industries. You will need to get some automobile specific domain knowledge that will not be provided through this course, because as you saw in this course, we are developing the smart Medibox. But the tools that you are learning here, PCB designing, for example, firmware development, all of those will definitely have an application in the auto electrical industry. If you're in the electronic space, in that embedded system space, for example, if you need to do like a mechanical alteration to a car, let's say your engine is giving you trouble, that knowledge will not be given here. All right. I hope you understand the difference. the embedded systems electronics focus will be delivered, but not the other mechanical component knowledge. If you have any follow-up questions, feel free to ask, but I hope I answered your question. Another question, is the course totally online? Willing to know the session's timing as I'm working full time? Yes, it is going to be totally online. Part of it will be delivered as recorded content, so you can watch it anytime. When I say anytime, that doesn't mean that you can watch it after you complete the course. You have to watch it according to a certain timetable, because when we have the live sessions where we guide you and work with you to develop the Medibox, you need to come to the class after watching that content. Otherwise, you will not understand, right? So that is the only restriction. You will be given enough time to watch the content, and then you come prepared for the class. Then we work together, because we will not have enough time to repeat the recorded content in class. That is why we expect you to watch and come. Any other questions?
Something to add to the class schedule. So the live sessions would be held on the days specified in the previous course schedule on Sundays from 9 a.m. to 11 a.m. So between that time period, that is the time period that we would be having the live sessions.
So let me try to go to that slide. So we'll give you like a detailed timeline. So now you know exactly when, like the exact start time and all that. But this is the schedule with the dates for now. See. Yes,
We would
please.
include the whole timetable, including the live sessions and their times on the LMS page. And also we would be creating a WhatsApp group or a Discord channel to maintain the communications, and we would be updating you on the class schedule in that group as well.
I hope that answered the question. Anything else?
There's another question. What is the next steps after completion of the course?
After completion of the course, or after, okay, let me answer both. One is, how do I put full screen? Sorry, okay, we'll have to deal with this for now. After completion of day one, I will walk you through the next steps. But if you're asking about the completion of the course, what will happen is like, we'll deliver these online sessions, and at the last day, we typically in our previous courses also, we have arranged an in-person session where all of us get together for the last day. And we will try to deliver your certificates also by then, so that you don't have to come twice to collect them. That is for those who complete the course. So at that time, it will be mainly networking, because we would like to like meet you in person, and we hope that it's beneficial for you as well to actually get to meet the people that gave you this information. So that is why we typically the last day we have an in-person session. And then on that day, we'll give you some future directions about what you can do, how you can build on top of the things that you know. Then also through SkillSurf, as I mentioned earlier, we have a couple of courses that are more advanced. I showed you. So if I go to the website, we'll show you what we have done in the past. So this is this course that we are dealing with right now. Here you can see we had an embedded product design for IoT course. So that is a more advanced course. Without this basic knowledge, you will not be able to take the advanced course. So that's one future thing. And then also we have delivered this embedded machine learning for edge computing. That is also another thing that you can do. These are future courses that builds on top of the knowledge of this course. Any other questions?
There's a question that I had received personally. How can I join the WhatsApp group? So Dr. Subodha will explain next how you can enroll in the course using the LMS platform. Then after you enroll, make the payment and enroll in the course, we would be adding you to the WhatsApp group, sending you an invitation to join the WhatsApp group for the enrolled participants.
There's a question, I think, the question is, which one is better, embedded machine learning versus IoT? Well, these are two different domains. In the IoT, I think you are referring to the more advanced courses that I showed you. The embedded product development course, that is on product development. And there we will be talking about more advanced concepts that build on top of this basic course. So there, last time what we did was we developed a smart plug that has some AC to DC, like power side things as well. Advanced PCB design, because we are dealing now with AC power and we need like real-time monitoring capabilities. There is power consumption monitoring, Wi-Fi through controlling like a relay that turns on and off the smart plug. So that is the advanced product that we developed in the IoT course. Embedded machine learning, on the other hand, that's, as I mentioned, it's a separate domain. There, what we did was we trained a few machine learning models, and then we implemented the inferencing part of it on microcontrollers. This particular application was one on gesture recognition. So you know that if you wave your hand, you orient your hand in a certain direction, you clench your fist, those kind of gestures can be recognized. Another one was wake word detection. Wake word detection is you say, hello Google, hey Siri, hey Alexa, those kind of wake words can you detect? So these are some of the applications that we did in the embedded machine learning course. The follow-up question from you is, which one is more relevant to automobile electronics side? I would say, if you are not having any machine learning on your automobile, then machine learning one will not be relevant. Then in that case, it will be the IoT one. Right, hope it's clear. You're welcome. Do we have any other questions? Right. Okay. Seeing no other, by the way, if you have anything else, please drop them in the chat. In the interest of time, I'm going to proceed. So I already introduced this to you. You know this as a part of the question. I gave this as an answer. So this is the hardware requirement. Again, it's not mandatory, but recommended. And here are the things that you can do to acquire the hardware. And we mentioned that you will be receiving a certificate ensuring or attesting to the fact that you completed the course. For you to get that, you need to complete the assignments. We don't take attendance, meaning that if you have any other commitments, it's okay not to come, but we recommend that you come because that is the only way that you can ask questions. Then we can have an interaction because these are more hands-on work. We highly recommend that you come, but that will not disqualify. If you don't come, that will not disqualify you from getting the certificate. The certificate solely depends on you completing the assignments. The first one being the wire diagram using Fritzing. Then the firmware and the simulation of smart Medibox, then the schematic and PCB design of the Medibox, and then finally the dashboard, the cloud dashboard that you built using Node-RED. So these things you need to complete, and even if you are, let's say you're stuck somewhere, that is why we are here. We'll help you. It is not going to be the case that we give you some instructions and we let you figure out what to do. No, we will develop this with you. We'll show you step by step. If you're stuck, we will tell you that, okay, try this, try doing this. And then if it doesn't work, try doing that. So it's going to be an interactive, continuous learning process. That's how the industry works. You do something, you show it to your reporting manager, your mentor, and he will guide you, he or she will guide you. and you iteratively improve. That is going to be the same thing that happens in this course. Now that the evaluation criteria is clear to you, this will be the team that will deliver the course. Most of them are here. You saw Abba, who gave the keynote, Chatuni, who was talking, like managing the entire session, and we also have Pahan, Dilanka, Tamidu, Kitmin, and myself and Dr. Ranga, who's behind the scenes and guiding everything. So that is the team that will deliver this course to you. As I mentioned, it's going to be outcome oriented, not a bunch of theory. So if you're taking the course, be prepared to get your hands dirty and do this with us. We always try to teach you the fundamentals with real world applications, in this case through the Medibox. And we have spent a significant amount of time, in addition to the time that we are spending delivering lectures, having these conversations, in developing the content for this course. So we've debated among ourselves, shall we say it like this or like this? Should this be the flow? Do we need to get this one before that one? So we've had all sorts of conversations over the years, and we have delivered this course now 2 times. This is the 3rd time, and we have refined the content based on the feedback that we get. So we've always believed in the fact that we need to keep on improving based on the feedback of the students, because you are the actual clients in this case, and we are the service providers. So the client actually has to give feedback and evaluate the service providers as well. So that is why we have continuously improved this. And if you look at, let's say, the first offering of this module, it is now different from what we are doing right now. It's actually significantly different from what we are doing right now. All right. Okay. So now, what can you do now? What do you have to do to take part in this course? This will be delivered through an LMS, okay, a learning management system. I will walk you through the learning management system, and how you can enroll in the course. The course fee is there to compensate the people spending time here. And we also have discounted rates available to different groups that we have communicated through email to you, so you know who you are. It will be conducted in English. If you have any language difficulties, we will be giving you Sinhala and Tamil explanations where required. So don't worry about it. Our team, as you can see, they are well versed in all 3 languages. So if you hit any roadblocks, let us know. We'll be happy to help, because language should not be a barrier for you to learn something, right? And I already touched upon this, recorded lectures published weekly, and then we'll go into a conversation, hands-on sessions based on that. And live discussions will be on Sundays. The schedule was given to you. We already answered this question, what can you do with what you learn? So I'm going to skip this and come to the point where we give you some instructions about what you need to do next. All right. So I'm going to stop sharing for a second and start sharing the LMS. Right. Okay. So I want to make one distinction clear. That is, this website, skillsurf.lk, this is where we advertise the courses to everyone. If you are enrolling in a course, you need to go to learnova. Let me log out so that you can see what to do from the very beginning. It's basically adding the word learnova in front of skillsurf.lk. So we'll be making all the links available to you so that you don't have to memorize or write it down. You can simply click on it and go. Learnova.skillsurf.lk, this is our LMS. So first you need to click on login. And if you don't already have an account, you need to click on sign up, right? So sign up with your name, first name, last name, email, and you create a password. You go through the terms and conditions, and then you check mark this and you sign up, right? So when you sign up, you will be shown a notification saying, please check your email to activate your account, right? So then the email that you added here, you should receive an email from this platform to that email address. Then you go there, you click on the activation link. Once you do that, your account will be activated. Then you can come here, you can click on login, and you can input your email and the password that you created to sign up. Right. So I already have created an account. So let me go in. Then you come to this courses page. So this cryptography fundamentals course, this is some other course that we are delivering. So when you come in, you will not see anything unless you have taken one of our previous courses through this LMS, right? Then what you have to do is you go here to this program catalog. When you go here, you will see this option, this microcontroller-based embedded system design. You go inside, right? Another thing to keep in mind. So before you click on this, we would appreciate if you can update your profile. There's a link to update your profile. Yeah, it's here, right? So you go here, you add your email, mobile number, you verify. And if you're adding a bio, you add a bio, right? So update your profile, verify your mobile number as well. That way we can keep in touch. And this information will automatically be populated when you are trying to purchase the course. So step 1, you sign up, you activate your account, you come here. This is the link. You can see here. You come here, you update your profile with your information. I mean, it's not too much, right? I mean, your first name, last name, that's already taken when you signed up. Email you add, your mobile number you add, and the password that was set before, right? So once you set it up, you come to courses, you go to the program catalog, and you come to our course. And the information, this is what you have seen before, nothing new, and you click on purchase. Then your name, last name, email, contact number will be populated through your profile. You can add your address here, city, and if you have received any coupon code, you can add here, and you click on. So let me just for now say 123 ABC Lane, and city is Colombo, and you click on checkout. Then you will be taken to this pay here page where you can pay using credit card or bank transfer, Genie, Freeme, whatever, right? So whatever pay here allows you to do, then you can make those payment even using a credit card. And once you add your credit card information and you click submit, you click pay, the payment will be processed and you will receive the confirmation. Right? So we as administrators will be able to see those who have enrolled in the module. So this admin account access, that will not be there for you. So under payment, everyone who completed, we'll be able to see, and we'll be sending you the confirmations that way, right? So I hope the process is clear. Right. So this is where we were. Now, that's how you enroll, and the deadline is 16th February by 3 p.m. So you have more than enough time to figure out and take part in the course. One small thing that I forgot to share with you when I was sharing the browser. So let me do that now. That is, when you go to skillsurf.lk and you click on, this is the home page, you click on view details, how to join. This page will be populated with the recording of this session, the one that we're having right now. So if anybody who could not come today, they want to watch, they can watch the recording. So if you have any friends who could not come to this live session, you can let them know. This recording will be here, and also we'll also create like a small clip showing you how to navigate the LMS, the one that I just showed you, so that you know how to sign up, the steps, right? And any questions or queries, you can reach out to these individuals. They'll be happy to help. So WhatsApp is the best mode of communication. So we'll make sure that we don't miss any of your questions, and we'll promptly get back to you, right? Okay. And the final few remarks, I think I can see that there are 11 questions that I did not read on the chat. I'll get to that. Final few remarks. Hardware, if you're requesting, it's the same deadline, 16th February. This Google form link, we will also add on the web page. So then you can request the hardware. Those who are requesting by this deadline will place an order in bulk, and we'll make sure that we deliver the items to you on time. So that once you go through the first few lectures, then then you will have the hardware ready with you so that you can develop the Medibox with us by the time we complete the first version or the first phase of it, and then later on we improve it. All right. What else? Okay. So yeah, course completion requirement to obtain the certificate, you must complete the evaluation criteria, attendance is not taken. Course materials available through, well, this actually should change to LMS. We actually had Moodle before, but we shifted from that to the custom LMS that we are using now. Then the course communications will happen through WhatsApp. The details are at our webpage. You can see the details at this page to change within the next. We'll upload everything, all the recordings within Monday. So by midnight Monday, you will see the skillsurf.lk website populated with all the information. Okay, so that's the information that we wanted to convey to you. Let's now again go and answer the questions that we have.
One small thing to add about the hardware component purchase. So the Google form that Dr. Subodha earlier showed is for you to show your interest in purchasing the hardware. You don't have to make any payment at that point. So after you fill that form, based on the number of requests that we get, we will prepare a finalized bill of material and finalize the prices considering the bulk that we are purchasing, and we'll share with you all the prices and how you can make the payment. And after that, after you complete the second set of Google Forms confirming your purchase, we'll only purchase these components for you. So you can, if you are interested in purchasing the hardware components, you can fill out this Google Form that we'll be sharing with you via an email. And you would be able to confirm your purchase afterwards, after considering the final prices.
Thank you, Chathani. Can we get an internship program after finishing this course? Well, about internships programs, we are working with industry. We will, so okay, here's something that happened. We had this system Verilog course that we conducted, and Synopsys was a partner for that. Synopsys actually inquired us, can we get the CVs of people who complete the course? Then we send the CVs. So that way, we will be keeping the industries informed, and if they request for the CVs, we'll be sending, but we cannot guarantee that you will get an internship after finishing this course. What we give you is the knowledge, and based on that, you get an interview and you demonstrate that you can actually do these things, then the company will be hiring you. So we'll be publicizing the fact that these courses are there. There are these graduates, similar to the previous example that I showed, that I told you. If we get a request, because we cannot force anyone to recruit people, if we get a request asking for CVs, then we'll share, then they might call you for an interview. That is the pathway we are following right now. In the future, if we can go for like a more concrete agreement with a particular company saying that people who are scoring like high marks from this program can get an internship, we'll go there, but we don't have that structure yet. Okay. There are a few questions about special discounts. So there were a few communications that went out about the discount codes that I don't remember exactly. Chathuni or Kitmin, will you be able to help? What are the discounts and the rates and all that? To whom are we offering that?
Yes, actually, we would be sharing all the details with you via an email. I guess we have to like finalize the exact discount amount that we are giving to which groups.
Yep. Yep.
So you can expect an email with all the payment details on the instructions about how you can make the payment, including a recording of the video that Dr. Subodha just showed, and all the instructions about how you can purchase the hardware and the discounts that you are eligible for. We'll be sharing all the details via an email. Itminaya, do you have anything to add to that?
I guess IEEE members definitely have a discount option. That is one of the groups. Yeah, we'll cover the rest via emails. I think that will be easy. Yes.
Yeah, thank you, Kitmin, for bringing that up. We have a MOU agreement with IEEE, so IEEE members, that's mainly for higher grade members. If they're taking, you have an active IEEE membership, there is a discount for them. All the other groups, we will keep you informed about the amounts and how to obtain that, because you saw when I was going through the LMS, there is a place to add a coupon code. So those will be provided to you so that you can get the discount. And there'll be some validation as well. I mean, because for example, if you say that you are an undergrad or an IEEE member, you need to be able to provide proof. So please make sure that you're prepared to do so. Question: if no Visa card, can we transfer the fees through online? In Pay Here, there are multiple options, and there's a bank transfer option as well. You can choose one of those options. If you're still facing any trouble, you can reach out to us through the contact numbers that are given on the website, and we'll be happy to help you. Anything else? I was trying to go to Mentimeter. Chatani or Kitmin, are you monitoring Mentimeter? Do we have any questions?
I think there's 2 questions on Mentimeter. Do you want me to read them out?
Yes, please.
Sure. Yeah, so the first question is how much is the course fee, and is there any offers to local undergraduates? I think this was covered. The second question, yes, the second question is how do we claim the 25% discount which is offered to IEEE members? I think we will be covering that with the additional information that will be mailing to everyone.
Yeah, we'll share that all that information with you by email. Question: any recommended book for this? Well, there is no one book that I can tell you. Even when we were preparing the materials, we referred like multiple material, not just books from all over the place. So there's no one book that I can recommend to you. We'll try to like give you some of the popular embedded systems books, but they will again be like very advanced stuff. I mean, like many concepts will be there. So better not read them right now. On the last day of the course, as next steps, I think that's a good place to give you some materials where you can self-study once you get this knowledge. So we'll provide you that during the course. Looks like we are okay, right? Yeah, I think so. So I don't see questions coming in. Right. So I think we covered everything that we had to cover for today. It took a little bit more than 2 hours than our original plan, but we are actually really happy to see that more than 40 people joined the session today, and we got like 150 plus registrations. So others will make the video recording available and we'll send a notification to you once that is ready. So we look forward to having most of you from day 2 onwards, and we look forward from our side deliver you like a excellent learning experience. That is our commitment to you. So see you from day 2 onwards of the microcontroller-based embedded system design course. Thank you very much for joining, everyone, and hope you have a good rest of your weekend and a good week ahead. Thank you.